So, yesterday you were part of the Dirty Secrets session, in which kind of uncomfortable problems of various theories were being discussed.
Yeah.
And you talked about the Copenhagen interpretation of quantum mechanics.
Yeah.
So could you give us just a brief reminder what the Copenhagen interpretation says?
Well, one of the things that I said was that the Copenhagen interpretation doesn't exist, right? It's supposed to refer to the ideas of the founders of quantum theory, people like Bohr and Heisenberg. So there are some themes within what they said, which you can say sort of form the core of Copenhagen type ideas, but it's not entirely clear what the actual full interpretation is, or exactly how to cash out all of those ideas into a fully coherent interpretation. So I would say there isn't a Copenhagen interpretation, but there are Copenhagen interpretations. I guess we should say what are the key ideas. What I view as like the core key ideas of this type of interpretation is that they're skeptical about the idea that the quantum formalism represents any direct picture of reality. Okay, so the idea is that everything in the quantum formalism really represents something about, for example, our knowledge about the world, but different versions of Copenhagenish interpretations will use different terminology. So the cubists are adamant that we're talking about our beliefs about the world, but you might also hear in other interpretations things like knowledge, information, advice. There's a Quantum Pragmatism by Richard Healy. He says quantum state represents advice about a quantum system. Bohr himself said, or was quoted by a second party as having said that quantum theory is about what we can say about reality.
So it is not describing reality per se,
right,
but it's just what we can say about reality.
Right. So the key common idea is that when you write down a quantum state, you're not talking about something that's an intrinsic property of a quantum system, right? A quantum system doesn't have a quantum state attached to it in the same way that a classical particle has a position, right? It's something that is in some sense more akin to like a probability distribution or something like that, representing some kind of knowledge or sort of uncertainty about the quantum system. So that's sort of key idea number one. Key idea number two is that also you say in Copenhagen type approaches, and there's nothing else, right? So in classical statistical mechanics, for instance, you also have the idea that the relevant state that you're talking about is a probability distribution over the microscopic properties of some system you're interested in. But there, you imagine that the system really has some microscopic properties, right? There's some point in phase space, each particle has a position and a momentum, and you just don't know exactly what that is. In Copenhagen type interpretations, you're saying the quantum state represents knowledge or uncertainty, but it's not sort of any deeper reality like that. So often people will say it's knowledge or information about outcomes of future measurements that you might make on the system, or something like that. There are various ways of talking about that, of course, but those are the two key points, right? This is not a literal description of reality, plus there is no deeper description of reality to be had, right? So those are the kind of core common features of what I would call, say, neo-Copenhagen interpretations.